There's a needle approaching Earth at the speed of light. A needle? Well, that's no big deal, right? Well, unfortunately, it's a very big deal. A needle traveling this fast can cause devastating effects on Earth. But why? This is What If Info, and here's what would happen. Okay, I'm going to let you know right away that this is a bad news, good news kind of story, and I'll tell you why in a bit. But first, let me explain to you exactly what the speed of light is. Well, the speed of light is how fast light travels, and in space, it will always travel at the same speed. No need to worry about drag or wind resistance, and it can travel around the Earth 7.5 times in a single second. If you were traveling at the speed of light, you'd be going very, very, very fast. No surprise there, but just how fast would you be going? Well, let's think about this in terms of one of my favorite trips, a ride to the moon. The moon is 386,400 km, 240,000 mi, away from Earth. It takes about 3 days, or 69 hours, for a spacecraft to go from Earth to the moon. But if you're traveling at the speed of light, this trip takes a mere 1.3 seconds. Why? Well, because you'd be traveling at 300,000 kilometers per second, 186,000 mph. The fastest human-made object ever made is the NASA Parker Solar Probe. And that only goes a measly 635,000 kmh, 394,000 mph. Light speed is the fastest speed that exists in the known universe. Nothing is able to travel faster than the speed of light, which brings us back to the good news part of this scenario. Creating a needle that can travel at the speed of light would be pretty much impossible. Well, we can look at Einstein's theory of relativity for our answer. According to his theory, as an object's speed gets close to the speed of light, its mass increases. And then, even more mind-boggling, time actually slows down. As the mass of the object increases, it would need more and more energy to speed it up. So, it gets harder and harder to push the object to the speed of light. Basically, you'd need to have an infinite amount of energy to make this happen. But let's say an advanced alien civilization has managed to get close to figuring out this physics problem. Instead of 100% of the speed of light, they've engineered a way to make a needle travel at 99.9% of the speed of light. Now you know that the needle is much, much tinier than Earth. If I were to try to tell you how much tinier, it'd be too hard to get all those zeros on the screen. But you get the idea, and because of its enormous speed, it's carrying a huge amount of kinetic energy. It may be tiny, but it can still do some serious harm because of the speed it's traveling at. So let's look at what happens when this needle hits Earth. What if it landed in the most beautiful spot in New York? I'm not talking about Times Square. I'm talking about Central Park. Central Park. As the needle hurtled through our atmosphere, there would be an enormous amount of friction generated. Now, we've seen spaceships ignite upon re-entry into Earth's atmosphere because of friction and heat in the air. Well, there's the possibility this needle would begin burning up too and disintegrating due to this enormous friction. But let's assume it keeps going. This fiery little needle would hit the park with a massive explosion. The impact would release a significant amount of energy that would radiate out as heat, light, and a massive shockwave. One estimate calculates that the energy released would be over 100 times the amount of energy from an exploding nuclear bomb. The trees, the grass, and the people in the park would be instantly incinerated by the enormous heat of the explosion. The tall buildings surrounding the park and further away in New York City would collapse like falling Jenga towers. Fires would start, and everything would start to burn. The explosion itself would create a giant fireball and a shockwave that would pulse out in waves. But the shockwave wouldn't just shake New York City. It would be massive enough to rock nearby states like New Jersey. The ground would shift beneath our feet. The energy released would be equal to the power of an earthquake that's about 7.3 on the Richter scale. We've had one like this before on Earth. In 1906, an earthquake that measured 7.9 on the Richter scale hit San Francisco. It destroyed over 28,000 buildings and killed more than 700 people. Would the impact of the needle on land cause worldwide destruction? Well, there's one scenario in which that might happen. and we'll get to that a little later. But it's also possible that the destruction caused would be limited to the point where the needle strikes and the surrounding areas. So, if you're living on the other side of the globe, you might just be lucky enough to avoid the horrific consequences. And speaking of destruction and survival, sometimes even everyday problems can feel catastrophic if you don't have the right tools. Like the last time I tried to scan an important document in bad lighting. Ended up with a blurry, unusable mess. That's why I tried iScanner. It's ranked among the top scanning apps worldwide with over 125 million downloads, and it turns any loose piece of paper into a professional-looking PDF, no matter what. Dim light, crooked angle, not a problem. Shaky hands, no judgment, doesn't matter. LoachNet. iScanner's AI cleans up the text, straightens the page, and even removes my fingers if they sneak into the shot. And it's not just scanning. You can edit PDF directly, use smart templates, and keep your documents safe with pin protection and a hidden folder option. I started using it at home for saving family photos, but it's also been a game changer here at work. Whether I'm in meetings, traveling through space, or drowning in contracts and receipts, when I'm not up here on the bridge telling you stories about the cosmos, iScanner makes sure my paperwork is handled instantly and looks professional. Why wait until your papers are lost or ruined? Just click the link in the description and grab 3 free months of iScanner Pro, with all features unlocked and 10 GB of cloud storage included. Scan now. Thank me later. Now let's get back to our fiery, light-speeding needle, because things only get wilder when it hits the ocean. Okay, so that's what would happen if this needle hit land, and the results are pretty devastating. But what would happen if this light-speed needle plunged into the ocean? Well, the impact would cause a massive amount of water to rise up into the air. The enormous amount of kinetic energy carried by the needle would explode into the ocean, creating a tidal wave. Would it set off a tsunami? Well, like I said, scientists estimate that this needle would give off as much energy as a nuke. That's over 1 megaton of TNT. This would definitely create a big splash. In 1946, in what was known as the Baker test, a 23-kiloton nuke was detonated underwater. This created a plume of water, 2 km, 1.3 miles high. Waves close to the explosion radiated out at heights of up to 30 meters, 100 feet. So our needle would probably cause a gigantic plume of water, but it's unlikely to generate a massive tsunami. That's because the needle would create an explosion at a single point in the water. But for a tsunami to happen, massive shifts in water are needed over vast areas. And that's only created by large geological movements like underwater earthquakes. So the good news is that you don't have to worry about a tsunami like the one in the Indian Ocean in 2004, which was equivalent to 23,000 Hiroshima bombs. Yeah, Mother Nature is a whole lot more powerful than this needle. Now this is what could happen to our planet, but what would happen if this needle hit you? What if it made a direct hit on a human body? This is a scenario where the bad news is infinite, since you'd be the first one absorbing this massive amount of kinetic energy. But the good news is you die instantly, so quickly that you probably wouldn't feel it. And you wouldn't have to go through all the devastating consequences that follow for anyone who survives. Now, there's a fourth possibility that could have far-reaching consequences for the entire world. What if the needle landed on the site of an active volcano? If this happened, the impact from the needle would create an opening for a lot of pent-up pressure to be released. It would disrupt the magma underground and set off a series of massive volcanic eruptions. Mass volcanic eruptions like this could cause an extinction event on Earth, just like they've done in Earth's past, over and over again. The Toba eruption 74,000 years ago almost wiped out all human beings. Only 2,000 to 20,000 humans survived that eruption and its aftermath. Volcanic ash thrown high into the atmosphere can linger there for 10 years or longer, blocking the sun. This could create a nuclear winter. With the sun's rays blocked, temperatures drop, and crops die out. Would there be any way for humans to survive this catastrophe? It's hard to see how humans could survive 10 years or more with our traditional agricultural systems thrown completely out of whack. As plants die, herbivorous animals will die out, and carnivores higher on the food chain will lose their prey. So, most animals will go extinct as our ecological chain collapses, but there is a slim ray of hope. Scientists have found that some parts of the southern hemisphere, like Australia and New Zealand, might be able to produce food in these very specific conditions. Conditions without much sunlight and low temperatures. But the grim truth is that these areas wouldn't be able to sustain our current global population of 8 billion people. The vast majority of humans would die out. But a small minority might remain a group of humans who would hopefully emerge hardier and stronger. I don't know about you, but I'm pretty relieved that the possibility of this tiny needle hitting Earth at light speed is close to zero. For once, I'm happy that we're nowhere near being able to produce an infinite amount of energy, and that we don't know of any advanced aliens with these capabilities either, thank goodness. But we don't need aliens to throw some other fun things down to Earth. Because even a small object moving at incredible but not light speeds can unleash dramatic consequences. What if instead of a sharp and deadly piece of metal, we tried something a little more appetizing? Ever had a freshly cooked steak delivered straight from the International Space Station? Let me tell you, it's not going to be what you expect. You must have so many questions right now. Salad or mashed potatoes? It's not every day that a chunk of meat falls from the sky. Astronauts on the International Space Station have precautions in place to keep anything from dropping down to Earth. But at the same time, they have to deal with spacesuit gloves that only allow about 20% of their gloveless range of motion. And sometimes things do slip away. Astronauts have dropped everything from a camera to a spatula. They use that thing for space shuttle repairs and not for cooking, in case you're wondering. What if you got to go to the ISS, and on your final spacewalk, a perfect cut of rib, steak slipped through your hands completely by accident? Before we get to the part where you're spacewalking with a piece of raw meat in your hands, we need to figure out how to get that meat there in the first place. The International Space Station has been continuously occupied since the end of 2000, but none of its visitors have been chefs. Astronauts have all their food pre-cooked here on Earth. Their meals either come ready to eat or can be easily prepared by adding water or by heating. Anything that hadn't been approved 6 months before your launch would be prohibited. You would break about 20 food regulations by sneaking raw meat aboard the IS, let alone by dropping that meat from orbit. There is a reason why dropping objects from the space station is a no-go and requires astronauts to report such incidents immediately. But let me go back to it in a moment. The ISS is orbiting 400 km above the Earth, 248 mi above the Earth. What do you say? We start the experiment with some closer to Earth cooking. As a side note, I'll eliminate some of the orbital effects from the story. For now, let's imagine that the steak you dropped would head straight down to the ground. When an item, like a steak, is plummeting to Earth from space, it moves really fast. And because of that high speed, the air in front of it can't get out of the way fast enough. It gets compressed. And when air is compressed, its molecules move faster, releasing kinetic energy. Things get hotter, but would it get hot enough to fry the steak? Let's see. If you drop the steak from a height of 70 kilometers, 43 mi, it would break the sound barrier. For about a minute, the air around it would heat up to 177 degrees C, 350 degrees F. If you've ever cooked steak, you know that this time and temperature isn't quite enough to cook the meat all the way through. When the steak hits the ground, it would still be far from well done. At 100 km, 62 mi, up, your ribeye would be falling at twice the speed of sound for 90 seconds. That's enough to add a little cooked crispness to its surface. Unfortunately, you'd still be eating raw steak, thanks to the sub-zero temperatures of the Earth's stratosphere. Dropping a steak down from 250 km, 155 mi, above Earth would get at that lovely seared surface. The falling meat would travel at 6 times the speed of sound, although it would still end up raw on the inside. If the steak fell from even higher above the atmosphere, its front shockwave would have temperatures reaching thousands of degrees. The meat's surface layer would start to burn off, looking more like flakes of carbon rather than a nice, medium-rare steak. But even dropping the steak from the ISS wouldn't give it enough time to cook through. You'd be eating a burned lump of protein that's raw red in the center. On Earth, it actually takes some degree of talent to cook a steak like that if you take away the burning part. Space makes for a horrible barbecue unless you prefer your steak raw with an ashy aftertaste. You'd also have to wait quite some time for a steak to reach your plate. If the IS itself were to fall from space, it would take 2.5 years due to the orbit it's in. Exactly how long it would take a steak to free fall from a height of 400 km, 248 mi, is uncertain. In reality, if we turn the orbital forces back on, your steak wouldn't actually make it to Earth. Your potential dinner would go into orbit first. Then, roughly 90 minutes later, it would be flying right back at the ISS at a speed of roughly 28,000 km/h, 17,500 mph. It might not hit the ISS, but if it did, you'd know it right away. Red meat is bad enough for you on Earth, but in space, it has the potential to wipe out an entire crew. If you're still up for the experiment, at least remember to sterilize the meat before you seal it in a pouch. And don't take cabbage, beans, or broccoli for a side dish. Those foods make astronauts fart. And that's never a good thing in close quarters. The only escape from that stinky situation would be taking a walk in outer space, maybe, with no spacesuit at all. But that's a story for another